Hey guys, welcome back. We've been looking at different file formats, their characteristics, and how to use them in our MapReduce programs. In this lesson, we are going to talk about a new file format named Avro. What is Avro and what is the need for it? And how do we read and write Avro files? And how we can use Avro with MapReduce. But before we talk about what is Avro, let's first try to understand the need for Avro. In my consulting career, I have worked with different clients. It usually surprises me how the teams in each organization is different in the way they work. In certain organizations, like banks for instance, all developers are asked or forced to stick to a programming language. For example, the company may insist all applications must be coded in Java. But in certain organizations, that is not the case. Developers are free to choose the programming language they want to use to solve a problem. As long as the work gets done, the programming language the developer uses is not a point of concern to the organization. There are pros and cons to each approaches, and we'll save the discussion for another session. When I was consulting for a well-known mobile company, programmers are given the freedom to choose the programming language that they would like to work on. I'm most comfortable with Java, so I used to work in Java, and my coworker doesn't want to do anything with Java, as he preferred languages like C++ and Python. And we both worked on the same team. So given this scenario, let's say I write a MapReduce program, where I have to output a user object in Java. I can easily do that using a sequence file, and the user object will be stored as a binary type. But if my buddy in my team wants to consume the output from my MapReduce program and read the Java user objects in Python, how can he do that? He won't be able to read the output that I produced using Java in Python, because the objects that I'm writing is in Java and his program to read the objects is written in Python. This is a serious problem, right? So how do we solve this problem? We can use a language-neutral data serialization system like Avro. Interestingly, Avro is created by Duck Cutting, who is also the creator of Hadoop. Avro is a high-level Apache project in itself, and it is important to note that its usage is not restricted with just Hadoop. Avro is used in places where you need inter-language portability, like the Java-Python scenario that I just described. In this lesson, we'll take a very simple object, like a user object for instance, with first name, last name, and address properties. And with a Java program, we will write those user objects using Avro serialization into a file. And next, we will be reading the file which we just created using Avro serialization in Python. Sounds like fun, right? So let's get started. To work with Avro, the objects that you're trying to write in Avro must confine to a structure or a schema. Why this is important? This is important because without an agreed schema, the programming language, that is Python for instance, trying to read the file will not have a clue about the object which was actually written using Java programming language. So the very first step is to define a schema for the object we are going to write. In our case, the user object. Schema in Avro are usually defined using JSON. And here's the schema of our user object. And this is how it looks like. The name of the object is the user. The type is the record, and you specify a namespace which is very similar to how you give a package name in Java. And here, for the namespace, we have specified com.hirw.avro. This user object has three fields or three properties: name, favorite number, and favorite color. And we're specifying the data type for each field in our schema. For example, the favorite number field is an integer field, and it can accept null values. Now our goal is to write user objects to a file using Avro serialization based on this schema. So take a look at this program. This program has three functions. The first function is to populate the user, and in the second function, serialized to Avro, we will write the user objects to a file using Avro. In the third function, deserialize from Avro, we will read the Avro file and print the user objects. Now in the same project, we also have the schema for the users, which is exactly the schema we saw on the slide. And here's the schema. So the very first thing we will do in the constructor is to get the schema stored in the file, which is exactly what we are doing here. We will then use the schema class from the Avro libraries to parse the schema which is stored in the file. And this is all the Avro classes which we have included in the file. This project, again a Mavenized project. And if you look at the pom.xml, we have included the Avro dependencies right here. Now going back to the program, now we have parsed the schema. Let's move on to the next method to actually create user objects using this schema. In the populate user function, let's create 3 user objects using the schema and using the generic data class. Remember from the schema that the favorite color or number properties can be null. In the first user object, we are leaving the color as null. And in the third object, we are leaving the number as null. Now we have 3 user objects created using this schema. The first user is Allison, the second user is Ben, and the third user is Charlie. Now it is time to write these 3 user objects into a file. And we'll do that in serialize to Avro method. Let's take a look at this method. In this method, you will use the data file writer to write user objects into a file. Let's first create a file named users.avro. And in the next 2 lines, we'll create a writer using the schema and call it data_dump writer. And using this writer, we are creating data file writer object to write a file in Avro using our schema. Now we are ready to add the user objects which we created earlier into the file users.avro using the append method. And once the objects are added, we'll use the close method on data writer to close the file. So now each user object is added to users.avro file as 3 separate Avro records in the file. So when we run our program, this function serialized to Avro will create a file named users.avro in our project. Although our end goal is to read this file using Python, just for the fun of it, we'll read the contents of this file using the deserialize from Avro method. In this method, we'll use the data file reader to read from the Avro file. We'll create a reader using the schema, and then using the reader, we'll create a reader to the file. We will then use the hasNext method on the reader to get each record from the Avro file one by one. A record is nothing but a user object. And finally, we are printing the user object. That is it. So this program will first populate 3 user objects, write those 3 user objects into an Avro file, and the third method, deserialize from Avro, will actually read the Avro file and print the contents of the Avro file. Let's go ahead and execute this program. It's a simple Java program, so I'm executing this program as a Java application. The program is now complete. It's a very short program. So if you refresh the project now, you'll see users.avro file is now created. If you open the file, it will not be in a readable format, but the very first thing you can notice is the Avro schema, which is actually the user schema embedded in the Avro file. And all our 3 user objects are serialized using Avro into this file. Now the deserialize to Avro method actually read this file and printed the results right here. Now looking back at the users.avro file, the schema that is embedded in the file is very important. With this schema, any program that is reading the file will know the structure of the objects stored in the file. Makes sense? So when you read this file from Python, the Python program will know the structure of the objects in this file and will be able to read the objects in the file. Now our goal is to use a program written in Python to read this file which was created using Java and to print the contents of this file. So now let's look at the Python program. Don't worry if you don't know Python. The program we will see has only few lines. We need to have Avro in the Python libraries first. To execute this program, you need to have Avro libraries for Python, which I have already added and configured in the cluster, so you don't have to worry about that. In the first few lines, we are importing and defining the Python classes so you can access them in your program. You're creating a data file reader by opening the Avro file first, and then using the reader object, you loop through to get and print all the user objects. The Avro file that we created using the Java program and this Python script is already in the cluster. So let's now go to the cluster and execute this Python script to read the Avro file and print the user objects. Executing this Python script is very simple. The Python script is stored in this location in the cluster, hirw workshop file formats avro read avro.py. And to execute the script, all you have to say is Python and give the location of the file. So copy this command and execute in the cluster. That is it. This script has actually read the Avro file, which is in this location, and has printed the user objects from the Avro file. This is powerful stuff, and this is made possible because we serialize the objects using Avro, which both Java and Python can understand using the Avro libraries. Now that we understand how to write Avro files using Java and also read the file contents back from Python, why don't we try a MapReduce program, and you guessed it, with Avro as the input. So this is what we'll do with our MapReduce program. In the Avro file which we just created, we have 3 user objects, and in each user object we have the name, favorite number, and color. The MapReduce program we are going to write is a very simple one, but good enough to demonstrate how to work with Avro files. In our MapReduce program, we are going to count the number of colors from our user objects. In each user object, we have the favorite color of the user. So for instance, in our data set, if we have 8 users whose favorite color is red, in the output we'll have red 8. If there are 4 users whose favorite color is blue, in the output we'll have blue 4. It is very similar to the word count problem. But before we look at the program, let's think about the contents of the input data set for a second. Since each record in our Avro data set is a user object, the mapper will be called with the user object one at a time. And from the user object, we can get the favorite color. Now, this user object is not a predefined type, like int writable or text. So how can we define the user object? Good thing is we have the schema for the user object, and with the one-line command we can generate the user object from the schema using the Avro library. Avro tools jar provide an easy way to get the user class in Java from the input schema. So with this one-line command, what we will do is we'll use the Avro tools.jar, we'll provide the user schema as input, and this will produce the user class as the output. So let's copy this command and execute this in our cluster. Now this command has produced the user class in Java, which we can use in our MapReduce program. So let's look at the output. There you go. There we see the file user.java. So let's open the file. There you go. So here is the user class which we can use in our MapReduce program. The very first thing you will see is it is auto-generated by Avro. And the next important thing I wanted to show you is the schema itself. Our schema is actually embedded in the class. And also here you go. There are 3 properties in this user object: name, favorite number, and favorite color. So Avro used the input schema that we provided and generated this entire file. So I've copied this exact same file into my Avro MapReduce project. Let's look at the driver program first. The driver program is very similar to any other driver program we have seen before. First, we'll specify the input and the output format. Let's make the input format to be Avro key input format and output format to be Avro key value output format. Next, we have to specify the type of the key value pair for the mapper's output. Our mapper will be called with an user object, and from the user object it will get the favorite color, and for the key it will output the color. And just like the word count problem, it will output 1 for value. So for instance, if the favorite color is red, the mapper will produce red 1. So for the key, we are going to make the type as text, and for value, we are going to make the type as int writable. Again, just like the word count problem. Next, we'll set the mapper and reducer classes. For this program, the input dataset is an Avro file, and the output dataset that we are going to produce will also be an Avro file. And we have to specify the schema for both. That is exactly what we'll do in these 3 lines. For the input format, we can get the schema from the user class that we just generated using Avro tools jar. As you can see in the user.java file, the schema is already embedded. The getSchema class method on the user object will get us the schema. For the output, we need to record the color as the key and the count for each color as the value. So for the output format, we specify string as the output key schema and integer as the output value schema. That is it for the driver. Let's move on to the mapper class. When you use Avro key input format, the user object from our Avro input dataset will be passed to the mapper as key. And that is all we care about. We'll make null writable for the value. And for the map output, we'll need to emit text and int writable, color for the key and 1 for the value. Here, from the user object, we get the favorite color, and if the color is null, we'll make it none. Finally, we will write the color and value 1 to the context to mark an occurrence of the color, just like the word count problem. Now, let's look at the reducer. In the reducer, we'll group all the colors and count the occurrences of each color. For the output, we have to emit Avro key and Avro value. For the Avro key, we'll write the color, and for the Avro value, let's write the count. That is it. Our program is now ready. Let's run this program into the cluster. I'm going to use Maven to produce the jar. So right-click, run as Maven build. This is going to package this entire project into a jar. I've already copied the jar to the cluster in this location right here. I'm also specifying the location of the input dataset and the location of the output dataset. The input dataset that we are going to use for this execution is the users.avro file that we created a little earlier in this lesson. So let's execute our MapReduce program. But before we do, let's delete the output directory if it's already there. So the output directory is now deleted. We are all clear to run our MapReduce program. There you go. The MapReduce program is now complete. Let's now review the output. Let's go to the output location and just do a listing on the output directory. There you go. This is our output file. As you can see, it is created with .avro file extension, which means our output dataset is an Avro file. Now let's bring the file locally and let's try to open the file. Let's use the copy to local command to bring the file locally so that we can look at the contents of the file. Let's open the file now using the VI editor. As expected, this file will have binary types and will not be in a readable format. Again, using the Avro tools jar, we can take an Avro file and display the contents of the Avro file in JSON format using this command right here. All you have to do is use the Avro tools.jar and use toJSON flag and give the Avro file as the input, and that's it. Let's try and execute this command. Here is the output from our MapReduce program in JSON format. As you can see, we only had 3 user objects in our dataset, with blue as the favorite color for one user, red as the favorite color for another, and for the third user, we did not specify a favorite color at all. We left it as null. So that is exactly what you're seeing here. That is it, guys. So let's summarize what we saw in this lesson. In this lesson, we saw a brand new file format called Avro. We created an Avro file using Java, and we read the same Avro file using a Python script. Finally, we created a MapReduce program to process an Avro dataset and write the output as Avro file as well. With that, let's wrap this lesson. See you in the next lesson.